Welcome to ServoSoft, the optimal solution. This tutorial helps you learn about the use of energy storage modules in ServoSoft, combined with the supply peak power optimization feature in both normal and backup operating modes. Its main objective is to model a system with energy storage modules, then optimize the supply peak power, taking advantage of the ESM energy storage, and then model the system when the main supply is lost in backup power mode. Please note that supply peak power optimization is available in the Pro version. First, I will review the power flow throughout the system with a focus on the ESM profiles. I will discuss each profile in the power versus time chart, starting from the bottom inverter profile up to the supply power. The inverter power profile shows the output power to the motor where positive and negative values are motoring and regen power to and from the motor. The energy storage solution profiles show how the energy storage module feeds power to the DC bus and stores excess energy in its capacitors. The ESS has its own capacitor bank that it controls, separate from the DC bus and its capacitors. Also, the available ESM energy storage is about 1 million joules, which is very large. Let's look at the chart in some details. For example, at 4 seconds, the inverter output is about 20.3 kilowatts, which is entirely supplied by the ESM, providing 21 kilowatts to the DC bus. Note how ESS energy is decreasing. In this case, the inverter efficiency is 97%, so the 21 kilowatts at the ESM output nets to 20.3 kilowatts at the inverter output. At 14 seconds, the opposite occurs, where the inverter is regenerating 16.5 kilowatts and the ESM is regenerating 16.1 kilowatts into its capacitors. Note how ESS energy is increasing. Again, the inverter efficiency is about 97%, confirmed by 16.1 divided by 16.5 kilowatts. The bus profiles show the power flow to and from the DC bus capacitors. The main supply power represents the power supplied from the mains. Without peak power optimization enabled, the supply power is somewhat spiky, with 22.5 kilowatt peak power. Utilities prefer smoother and ideally continuous power demand. Let's see what we can do about this. Next, I will show how when using supply peak power optimization, the supply power can be reduced from 22 kilowatts to 2.05 kilowatts. So, if I limit the supply max power to 2050 watts, the supply power drops to just 2050 watts. This is possible because of large ESM energy storage. The Axis 1 infeed delivers constant power of 1,989 watts to the DC bus, and the ESM is doing most of the work storing and delivering the energy swings as needed throughout the cycle. The net result is a 10-time reduction in peak power at the mains. So, what happens if the main supply is lost at 30 seconds? Let's change to backup power mode and set to 30 seconds with duration of 25 seconds. Starting at 30 seconds until 55 seconds, the main supply is 0, and the ESS does all the work. This is why so much ESS energy storage was selected. The green background shows how the system can continue to run without issue for the entire duration of power loss. The system can easily handle the second half of the sequence with plenty of energy storage to spare. If I reduce the ESM energy storage capacitance by 7,000 millifarads, then at 35.5 seconds, the ESM does not have enough peak power to keep the system running. Adjusting the capacitance values are meant for scenario analysis, for example, to determine how much energy reserve is available, or how much additional energy storage is needed. In this case, by decreasing capacitance by 7,000 millifarads, the system cannot meet the inverter output profile demand, and this is shown clearly by the red background starting at 35.5 seconds. I'll drill down a little bit at this exact moment at 35.5 seconds. The ESM is running at maximum current of 80 amps. As energy is taken from the ESS, the capacitor voltage decreases to 275 volts. 80 amps times 275 volts equals 22 kilowatts, but 21.4 kilowatts divided by 0.97 equals 22.06 kilowatts that is needed. This means the ESS could not deliver the peak power required at that moment. This concludes the tutorial on energy storage modules. Thank you.